Hi everyone, welcome back to another video. So one of the questions that I get asked all the time is about plant growth regulators. So how to use them, which ones to use it, and how much to use it. So on this video, I want to answer all of those questions. All right, so plant growth regulators. So pretty much what is plant growth regulators? So plant growth regulators are plant hormones used to alter the growth of the plants. In general, or in tissue culture, we mostly care about auxins and cytokinins. And there are some other hormones like some gibberellic acid, ethylene gas, and also some other substances. However, for tissue culture, you must pretty much have to consider auxins and cytokinins. Auxin is mostly for to produce roots, and cytokinins is to produce multiplication or like cell divisions. So there are so many cytokinins, and the ratio between auxin and cytokinins is going to pretty much change what the plant is making. So if I have so this is kind of a graph or base. If I have about the same amount of auxin and cytokinins, let's say 1 milliliter of each, let's say a BA and like NAA or IBA, for general, in general, you may see quite a low callus. So you have about the same amount of hormones. You're going to end up with a bunch of callus. It's not always true, but in general, for a lot of the plants, that's what you end up seeing. You have a lot more cytokinins compared to auxin. So you see on my multiplication media that I use all the time, I use 1 milliliter of BA to zero point 0.1 or 10 times less auxins, which is IBA or NAA or any whatever other auxin that I use. So it is usually around 10 times less. It can be more or less, kind of depends on the plant. But in general, if you have a higher amount of cytokinin compared to the auxin, is when you are doing the multiplication. Is the multiplication stage. That's when the plants are. That's when you want to multiply as many plants as possible. And this is the media that I pretty much use all the time. I very rarely use routine media. Now, if you want to use a routine media, what you do? Well, you reverse the ratios of the auxin and cytokinin. So instead of having a high amount of auxin, now you're going to have a high amount of cytokinin. Now you're going to change it, and you want to have a high amount of auxin. So, for example, for example, now I will have 1 milliliter of IBA and zero point 0.1 milliliters of BAP, or even I may use eliminate the BAP. If I don't need to multiply more plants, I just need them to grow bigger and to produce roots. I'll just essentially just increase the amount of auxin, which is just my rooting hormone. So that's when you start seeing the root formation on the plants. So let's talk about a little bit about some of the auxins. So auxins produce like cell elongation, so that's when the plants grow bigger, because when you have in multiplication media, you may have a ton of plants, but they were really, really small. And then when you change the media to like some people call it like the grow media or like rooting media. It's basically you have a lot more auxin, so the plants are you have bigger cell elongations, so the plants they just get bigger, and then you get the root formation. So some of the auxins we have like IAA, which occurs naturally in plants. Um, it is best known as a plant propagator. When you purchase the rooting hormone, it can be like the powder or like the gel. If you look on it is on the ingredients, it's most likely going to be IAA, or pretty much all the time is IAA. And this is a great rooting hormone that is used on traditional cloning and also used in tissue culture. The disadvantage of using IAA is that it is naturally producing plants, which is great. However, when in tissue culture, it's not heat stable. So you have to sterilize the media, which to sterilize the media, you want to heat it up to 121 degrees Celsius for like 15-20 minutes, or depending how much media you're making. However, IAA it is not heat stable, so you have to add it after you sterilize the media and the media has cooled down to around at least 60 degrees Celsius. So that is a little bit of a disadvantage because that means that you had to add it in the hood. So you had to make the media in like a media bottom, and then you had to use syringe. You had to filter sterilize the Auxin, the IAA, and then you had to add it using very much sterile conditions. So that means if you don't have a laminar flow hood, I will avoid using the like IAA or most for the most point in general like natural hormones because they're usually not heat stable. Usually synthetic hormones, those are the ones that are heat stable, and those are the ones that I like to use them the most because I don't have to add them after I sterilize the media. I can add them directly when I'm making my own media. So that's the reason why I like to use IBA, which is also a naturally occurring hormone, but it's also made synthetically. So when we work in tissue culture, we are using the synthetic form, which is a more stable. It is a heat stable, so it is a lot easier to use. I can just add it while I'm making my media. Then NAA, it is also a synthetic auxin. It is great for to promote it is great for promoting roots. However, it also promotes a lot of like callus formation. So if you're looking to grow callus, NAA is great. However, in most cases, especially for like houseplants, and I don't want to have a grow callus. So I don't. Um, about a year ago, I switched my media from using NAA to using IBA, and pretty much I already made a couple of videos mentioning that, but you're still not aware. That's something that I changed the use from NAA because it produces a lot of callus on my plants to IBA, which is makes the plant look a little more natural, and they're a lot easier for me to take it out of culture and place it in soil. They root a lot faster. With the one in NAA, I get a lot of callus, and I still get roots, but I get a lot of callus, which I don't want. A callus doesn't really do anything outside of tissue culture; it just dies. So it just I still use it, but not in house plants. I would say in carnivorous plants, like in Venus flytraps, they love NAA, and I don't have problems having callus with NAA on like most carnivorous plants, like Venus flytraps or some Drosera or Pinguicula. They love it. So you can you can use NAA on carnivorous plants. I use both NAA and IBA. I haven't really done much like I won't say research, but I haven't done a lot of that much testing on see which ones grows produces more plants or which ones make the plants grow faster or bigger. That's something I would like to test it out. So about a year ago, I have a kind of a series which I kind of haven't been able to work that much, where I'm trying to find the best media for I have it for house plants, but I want to try on other different plants. So I want to also try for carnivorous plants. I want to try for some philodendrons, for monstera, because they're going to be a little bit different, and maybe some other plants. So that's something that hopefully in the future I will have more time for me to be able to run more experiments and be able to experiment which hormones were the best for each plant. But as for right now, kind of general rule is that IBA works great for houseplants. NAA both works great for both houseplants and carnivorous plants. Um, uh, but yeah, you will see some callus grow. Now, you definitely want to grow callus. 2,4-D is a synthetic auxin. It's mostly a weed killer, so it kills broadleaf weeds that you see on your garden. So you spray your lawn, you want to kill the broadleaf weeds, and but don't harm the grass. So that's what 2,4-D does. And in tissue culture is mostly used to introduce callus in the plants. So again, I want to run some experiments. I did an experiment where I have trying to grow to regenerate plants using leaves instead of nodes. And I think the use of 2,4-D will help me out on that. But like again, I still need to run the more experiments to see what happens. So hopefully I can get that work done soon, and then I will let you know. I will document everything. I'll let you know what happens. So now let's move on to cytokinin. So cytokinins are induce like cell. They help with the cell division, shoe multiplication, and auxiliary. But um, these are the hormones used for multiplication. So the most common one is like BA or like BAP. It is used on culture media to promote auxiliary bud growth. It is synthetic plant growth regulator, and it is great for pretty much most plants. So I would say it's probably one of the most common hormones used in tissue culture. And it is the amount of plants, the amount of multiplication you get from BA is it is a lot. You get a lot of plants. So with house plants, that's what I'm pretty much that's what I use the most in houseplants. I use about 1 milliliter per liter in general of BA. For some plants, like the ones that grow really slow, like the monsteras or some of the philodendrons, I increase the amount of BA to around maybe 3 milliliters. If you use too much BA, you may see some callus grow. So that's something that you may want to be careful if you don't want to have any callus grow. But BA, it is great. One of the things I will say about BA is that you're going to get a ton of plants, like so many plants, and a lot, and those plants will be very clumpy. So they will be like a lot of plants, but going to be really, usually it's really small and very clumpy. Um, so that's why you use it on multiplication. After I get enough plants, then I will reduce the amount of BA. A lot of times I just completely eliminate the amount of BA, and then I increase the amount of IBA, which is my auxin, to be able to grow the plants bigger and hopefully grow roots. Sometimes it's difficult to grow roots on some of these plants. And then I finally take it out of tissue culture and place it in soil. So, but with BA, you get a ton of plants, but they're going to be very compact, very clumpy, very small. So, if you want to have larger plants, then maybe a kinetic may be a good option for you. So, it also induce cell division. Um, the only thing with Kinetin is that you will get bigger plants than using BA. The only thing is that the amount of multiplication is going to be significantly lower. So that's something that you may want to play with. Is like if you already have a ton of plants and you're really looking into get like bigger plants, maybe Kinetic is a good option. But if you want to get the most amount of plants in the shortest amount of time, you may want to stick with BA, as it is a more effective on multiplying plants. Now with BA, I can use just BA only. I don't have to add any Auxin, so I don't have to add the IBA for me to propagate the plants. With Kinetic, you still need to add the Auxins to be able the kinetic works. For some reason, if you add the kinetic, it may help with multiplication, but it's a lot more effective when you add an auxin, which either can be an AA, IBA, or IAA. It's going to increase. They work together, and they help promote the callus formation, like a shoot proliferation. Now, TDC is the one of the most active cytokinins. It's mostly used on like woody plants. So you're working with like rhododendrons or like some trees. I have used it before for trees, or like something like bushes, like blueberries, raspberries, stuff like that. TDC, it is very effective. It is use it normally in like smaller quantities. So if I say that I use like 1 milliliter of BA for TDC, you have to use a lot less. You still need to look on research papers to know how much to use, because it kind of depends a lot on whichever plants you're working with. But in general, you're going to use a lot lower dose than you would use with like Kinetic or like BA. However, you have to be careful with you use it too much TDC because it can also inhibit shoot elongation. So again, you want that ton of like a really small plants, which is not great. All right, so those are kind of the most general plant regulators. Now let me talk about some other plant regulators that are not very used that much in tissue culture, but they're still important. So for example, we have gibberellic acid, which is a naturally occurring substance that influences cell elongation and cell enlargement and stem elongation. It is often used in plant tissue culture or like in the media, the plant tissue culture, as it helps um, the with the dormancy of seeds. So you can use it in different ways. You can either soak the seeds on gibberellic acid for a certain amount of time. Again, you have to look on the research paper to know how much to use for different seeds. They are different, and to break dormancy, or you can add it directly to the media, which it also helps with the breaking the dormancy. It's also used for cell elongation. So as I was just saying about the use of BA, where you get a ton of really small plants, a lot of plants, but they are very small. If you add gibberellic acid, you will get larger plants, and you still get a lot of multiplication. I don't really add it. I don't add it to my media because for me it's just like another ingredient that I need to get, and it is not really that much. I don't see much of the use. I rather have because if I'm using multiplication, I don't really mind if I have really small plants, but I'm really looking for the numbers. Afterwards, I can just transfer to media without BA or lower the amount of BA and then get bigger plants. So I don't really add or use the gibberellic acid as much. Now, ethylene gas. Ethylene gas is the only gaseous plant regulators is associated with fruit ripening. So let's say you have an apple and then you have like a banana in like the same uh, fruit bowl, and they both want to ripen faster than they will be like separate because what they produce ethylene gas, and which makes the fruit mature a lot faster. Um, it also promotes flowering and leaf senescence, which I mean, there are some things. I mean, it is useful for some things. However, ethylene gas is bad in tissue culture. The buildup of ethylene gas in tissue culture vessels will cause the sudden death of your plants. So you may have plants that they look normal, healthy, and then out of the sudden, in like a matter of just a few days, they're going to be completely. I mean, they're going to be dead. They're completely black or like brown. They usually turn brown really fast, and can you also see on the media it kind of turns the media brownish, and then you realize like what is going on, why use out the sun and use the plants use that, and it's because they was the buildup of ethylene gas inside of your tissue culture vessel. And one way to prevent it is you can have vented containers. You can either make like a small hole and put some like something like a micropore tape or like a mushroom filters, or you can use um, something like a temporary immersion bioreactors, which use gas exchange, something like very similar to the biocoupler uses to prevent the buildup of ethylene gas. Now, in my experience, I haven't seen that much issues, at least not in my lab with ethylene gas. I see it every now and then on like pinguicula or Mexican pinguicula, that's carnivorous plants. But in general, house plants I haven't seen that much or at all. So if now I don't bend my flats, I may have some plants that are vented, and that's fine. Or I have some like the biocoppers which are also vented. However, you say like, well, should I bend all my containers to prevent ethylene gas? I would not do it unless you're actually seeing the sudden death in your plants, and then you may have some ethylene gas buildup. But it's not going to be on every single plant, so you don't have to have vented containers for every single of your tissue culture cultures. If you had the issue, then you may want to have vented containers, but If the plants are growing fine and there is no problem, I just want to save the hustle on painting all the containers, or just getting painted containers, which are usually a bit more expensive than just the regular containers. So that's pretty much what it was. Ethylene gas. For the plant grow regulators again, what is the dose? The dose, at least the one that I use for my plants, I always use the same media, which I have mentioned in multiple times. So it is full ms, at least for houseplant, is full ms media, 30 grams of sugar, 1 milliliter of ba or bap, 0.1 milliliters of iba, and use agar or gelangum, depending on which plants you're working with. I will make a video on agar versus gelangum, which ones to choose for which plants in the future. Um, but at least for plant growth regulators, that's usually what I use. If for other plants like monsteras, then I will increase the amount of BA to around 3 milliliters per liter, because monsteras, um, they multiply a lot slower and they produce a lot of roots. Even with 3 milliliters, I still get a lot of roots, which in multiplication stage, I don't want any roots. I just want to multiply as many plants as possible. Um, but if I go over 3 milliliters, then I start seeing some callus formation, or I may start seeing some of the plants not really, the more you add the BA, you may think that is the best, but sometimes it actually slows down the multiplication. So I found that about 3 milliliters for like monsteras is about the sweet spot, and about 1 milliliter for pretty much most of the other houseplants works great. Alocasia, also I have also done like 2 to 3 milliliters, and that has done really well, especially in the biocouplers. I did a couple of videos ago. I did like my alocasia blackberry variegated in like one biocoupler, which a lot of people were asking me why it was all white and everything. Is like, well, it was so white because it was only the corms. It didn't have any leaves, which it was great because it doesn't have any leaves, but it's multiplying exponentially. I have a ton of plants in that in one biocoupler, which it was great. I increased the amount of cytokinin. That's why I got that result. Now I transfer all those plants to growing media, so it doesn't have it still has BA, but it has a lot less. It has like 0.1 milliliters of BA, and it has 1 milliliter of IBA, which my goal is now to make it grow leaves and hopefully grow roots. Now, something I want to say about alocasias. If you're purchasing alocasias in tissue culture, most likely they will lose the leaves anyways. They are really picky. You may already know that. Whenever you get a plant and then you transfer either to new media or to soil, a lot of the times the leaves they're just going to wilt. They are not really going to do that well. But anyways, that's pretty much for house plants. For carnivorous plants, about the same, I would say. Um, about 1 milliliter of BA or BAP, and for the NAA about the same, or well, BA or NAA. For carnivorous plants, I have found that really doesn't matter which one you use. You still get a ton of good growth. Um, but like I say, I still need to do the experiments to see which one is more effective. So stay tuned for that. And pretty much that's everything. Now this is one little parts of the some of the slides from the tissue culture masterclass. So if you are interested in taking the tissue culture masterclass and taking the pretty much the entire class, make sure to sign up for the next class, which is going to be on January. So I'm very excited about that. It's also going to be another virtual class. It's going to be in January, and like I said, this is just a small part of the class. So you're interested in taking that, make sure to sign out. Link is down in the description. Hope you have enjoyed it, and I'll see you next time. Goodbye. Thanks for watching the video. If you are enjoying these tissue culture videos, make sure to follow us on social media for more informative content. And if you are interested on conducting your own tissue culture experiments, make sure to check us out at plantsafetechnology.com for all the products you need to get started. Use code FP10 for 10% off on your first purchase.